This is very calculus based. Okay, so you're trying to find the derivative of this thing right here, and you do it like first with respect to x, then with respect to y. But with respect to x, when you're doing fx, you treat y as a constant. So what that means is like, and you can like mentally, like instead of y, you can see like 3. So if this is 3, natural log 7x plus 4 times 3, the derivative of this, the derivative of ln is always 1 over. So your derivative is 3 times 1 over natural log of whatever the inside function is. But then you have to take the derivative of the inside function, and the derivative of the inside function is just 7. Do you remember any of that from a calculus class? Okay, well that's good. That's a good starting point. Now it's not 3 though. It's y, and it's not 3 down there either. It's y. Okay, but like your final simplified answer here is 7 7y over natural log 7x plus 4y. And that's for fx. Fy is slightly more complicated. Are you able to enter that? Do you feel comfortable doing that over here with this? Can you enter that?
Yeah, I can enter it, and it will like tell me if it's right at the end though.
Okay, so this is not question by question. So let's go to Fy now, whenever you're ready for that.
Okay.
So this time when you're doing it, when you're trying to find Fy, that means that you treat x as a constant. Okay, but this one's more complicated. It's product rule. Because it's the y is the first function and natural log of this is your second. So you have to remember your product rule. Your product rule was this. Your derivative was u v prime plus v u prime. Maybe remember that. So in this case, your Fy is, we're going to keep the first, but we're going to take the derivative of the second. So it's 1 over 7x plus 4y, but then there's the chain rule. You got to take the derivative of the inside function, but you're doing it with respect to y, so it's just 4.
Why didn't you put the ln on the bottom like you did the first time?
I'm so sorry. That's completely wrong. That is completely wrong. It is just 1 over. I don't know why I did that.
Oh, okay. So the ln doesn't go there.
Yeah.
Okay.
That's really silly of me. Okay, so now, so we've done this uv prime. So next is, what's the derivative of y? The derivative of y is just 1, and then you keep the next part here. Okay, so it's simplified here, 4y over 7x plus 4y plus natural log 7x plus 4y.
Okay.
Close parenthesis.
All right, I will send the next screenshot. Can I send screenshots in the chat?
You can. Very few people use the chat, so it may take me a moment to actually get the files, but sure. Yes, drop them in there. Whatever's easiest. I'll quickly get caught up.
I can do the email. That's if it's
either, it doesn't matter. Whatever. Yeah, whatever you want here.
Okay, should have just sent.
All right, there it is. New screenshot here. Okay. No, we just did that. To me, I'm seeing the same.
Oh, did I send the same one?
Yeah.
Okay.
There it is. Great. Okay. All right. So next question here is, so it's a new function. Okay. And some, it's the same problem. Like there's different notations, but this first one means take the derivative of this thing with respect to X. And you know, you got to remember all the rules you learned previously. So the derivative of E is itself.
Mhm.
Okay, derivative is itself, but there's always chain rule. So the derivative of the inside function just with respect to X is 7, because like 4 times Y, even though it's a variable there, you treat it as a constant. Like it might as well be 4 times 10. Doesn't really matter. Derivative of constant is that. So simplified, it's negative 35E 7X minus 4Y. Then the next one, you do the same thing. What you'll notice if you do a lot of these on your own is that there's a lot of overlap between them.
Mhm.
The derivative though now with respect to Y is the derivative of this inside part just negative 4. Because you treat the X as if it's a constant, derivatives of constants are 0. So this is 20E to the 7X minus 4Y.
Okay. Yeah, those ones I understand a little bit more. Or like those ones aren't as hard for me. It's just annoying because I am not sure like what I am supposed to do.
Yeah. Well, let's see if again, like it does get easier. This is actually something you would see in third semester of calculus, but they kind of briefly touch on it here, and then they don't. You have it for like a week or two, and then they don't touch it again for the rest of the course. It's not like this is the rest of the math class.
Yeah. Okay.
Right. I hear something
Yeah.
on your side.
Yeah, I should have sent.
There it is. Okay. All right. All right, so here's your next question. So you can actually find these partial derivatives with respect to any variable. They're basically telling you that like it's X and Y, and lambda is this third variable. A lot of times they go X, Y, and Z, but you can also do the following. You can always take do a rewrite step. We could have done it with the last one, but it potentially will make more sense here. You can distribute this lambda, and so it's minus 5 lambda x minus 9 lambda y plus 21 lambda. And this rewrite step can potentially help taking derivatives here. So your fx, you only care about something that's got an x in it. So see how this first one has an x in it? So
Yeah.
you take its derivative. That's
Okay.
0. Derivative with what? 0. The next one has an x in it. And it doesn't matter that there's a lambda. Lambda is a constant. You treat anything else besides x as a constant. So y and lambda are constants. So this is minus 5 lambda. There's no x's here, so that's minus 0. No x's here, plus 0. So your reduced to your form is 2x minus 5 lambda, and you can make it nice if you want to, kind of like this one, but the key though is recognizing if it doesn't have an x, like these don't have an x, you just ignore them.
Okay, so you didn't have to find the derivative of the negative 5 lambda x. You just had to take the x out.
You do. The derivative, like d dx of a constant times x is the constant. And so it's like whatever's in front of x, like d dx of 5 lambda pi over 4 times x is 5 lambda pi over 4.
Okay.
It's whatever's in front of x becomes the derivative.
Okay.
When it's x to the 1.
Okay. So then like for f of y,
Yes.
or whatever, you say it would be 0 plus 2y minus 9 lambda.
Yep.
And that would be it.
Yep.
Okay.
So it simplifies to 2y minus 9 lambda. Are you any chance you're going to go into economics here?
Like in this class?
No. Upper division economics classes do rely on some of this stuff that's going on here.
Oh, yeah, probably.
Okay. So like your econ 300, 400 levels, there's a couple classes there where you have to do some of this type of work again.
Okay.
So that's where it comes back. For the last one, unless it has a lambda, you just ignore it. So you know, x squared, derivative of x squared is 0, derivative of y squared is 0. This time though, and this again, you could rewrite this. So you could rewrite it as minus 5x lambda.
Mhm.
And then the derivative is minus 5x, because it's like whatever's in front of lambda is your variable. Same thing here. You could write this as minus 9y lambda. So the derivative is whatever's in front of lambda minus 9y.
Okay.
And then again here, whatever's in front of lambda plus 21.
Okay.
And just a reminder to always double check what you're entering before you submit, because there's no partial credit on these.
Yeah.
As you know, it's
Okay. I will send the next one over.
all right. Standing by for that.
Yep, it should have just sent.
All right. There it is. Great. Wait. It looks like one we've already done.
Oh, really? Okay.
It looks like, yeah. No. I'm wrong. It just looks, it's just a lot like this. Is it minus 5e to the 4x minus 5y?
Yeah.
Okay.
Is that like the one we did above?
Yes.
Okay,
It's
so it'd be
almost
negative 20e to the 4x minus
yes.
5y.
Uh-huh.
Okay, and then that would be 25e to the 4x.
Yes. Yes. So after you do a few, you see the pattern and
Okay, yeah. Wait, I think I'm messing up. Hold on.
for which one?
I sent you the wrong.
Oh, okay. Okay.
Here we go. Okay. It didn't like register that I completed the quiz, so it was still open, and
Okay.
it was just my
Hmm.
not very
Well, it's Monday. It's a day off. You know,
yeah.
you're getting a gold star for actually wanting to do school today.
All right, let's see that one.
Got it. Here it is. Yeah, so these are now finding second derivatives.
Okay.
So the process is to basically go again in a couple of these cases. So there's so there's sort of this path here. I guess I'll draw off to the side here. So you're given a function of x and y, and your teacher probably showed you this in class, but there's first take the derivative with respect to x. And then if you take it again, that's what's called fxx. Okay, and we'll do that first, and then we'll come back to this. So the first derivative here, and you actually do have to write some of these with respect to x is just 5.
Okay.
Because you anything with a y in it you just ignore. But we don't want that. We want fxx. So we want to take another derivative here. What is the derivative of a constant? It's
0.
0. Excuse me, 0.
Okay. And then that would be the same for f, like y.
Yeah, but let me just like kind of there's a bit more here. If we just go through this a little, like, yeah, we'll do fy, and what I like to do is kind of do it off to the side here, and then there's fyy. So fy is 8, fyy is 0. Okay, but there's this other thing called fxy and fyx that's in the middle here.
Okay.
So what fxy is you move from this one right here, and you take the derivative of this with respect to y. Now it doesn't make any sense because there's no y's here in this one. So fxy, see, it's just the derivative of a constant. It's still 0.
Okay.
Okay, it'll make sense in the next example we look at. But when you go here, when you do fyx, you're taking the derivative of this with respect to x. It is also 0.
Okay.
Because these are actually the same. fxy equals fyx. And this is, you don't need to know this because you'll just intuitively get to here, but there's kind of a nice progression to work these problems out with.
Okay.
And it'll make more sense the next one, I promise. This is not a good example for this, but.
So they're all 0?
Yes.
That's easy enough. Hopefully
Yes.
I get something like that on my test.
Yes. We want that. Maybe your test will be replicas of these quizzes, and you'll have a feel for how to do it.
Yeah, it looks like the other one should be a better example.
Okay. There it is. And it is. All right. So let's do, so like they're again kind of like this, there's this like nice progression that we can do here. And I would recommend first finding fx. Okay, so like when I look at this thing up here, the y's are constant. So if you need to, you can rewrite it like as 8y to the 8th x to the 6th plus 6y to the 4th x to the 7th. And the reason is because this stuff right here is just constant. It just comes along with it. And so the derivative of x to the 6th is power rule, x to the 7th is power rule.
Okay.
So like I'll show it out here. And so it's 8y to the 8th. The derivative of x to the 6th is 6x to the 5th. Plus 6y to the 4th, and the derivative of x to the 7th is 7x to the 6th. Now, when you get more comfortable with this, you'll multiply these right away. It's 48, and then y to the 8th, x to the 5th, if you want here, plus 42, y to the 5th, x to the 6th. Now, notice that's not one that they're looking for. They want fxx.
Yes.
So you got to do this again, but it's just power rule. It's just 5 times that, 6 times that, and because these are just constants. So it's like 240 y to the 8th, x to the 4th. And then 6 times 252, y to the 5th, x to the 5th. And please double check me, since this is a quiz. I can also use a calculator to confirm, but
Okay. And that's a, oh yeah, I guess that's the whole, that's just f of x.
XXX.
Okay.
We just, the XXX, FX is the previous line, and then you do it again to get the next line down.
Okay. Let me just type it in really quickly.
So let me know when I can move on to FYY or FY.
Yeah, you can move on.
Okay, so again, like to find FY, you may find it's more convenient to rewrite it, but this one's already kind of nicely rewritten because the X's are treated as constants. So it's just power rule. So you're gonna, you know, this is 8y to the 7th. So you take that 8 and you multiply by that one. So you get 64 x to the 6th, y to the 7th, plus this 4 times 6, power rule, right? 24 x to the 7th, y to the 3rd. Okay, but then you got to do it again, FY, Y. So now you got to take this 7 and multiply it by 64. So that's like 420 plus 28, 448, x to the 6th, y to the 6th, plus 3 times 24, 72, x to the 7th, y squared. And that's that last box there.
Okay.
Oh, I'm sorry, it's the second box. I guess they did these in a different order. Second. So whenever you get that down, we can do fxy.
Okay.
And again, like you can either start from this line or this line, because they're going to turn into exactly the same thing. If you start with this line, which is fx, you want to take fxy, the derivative of this with respect to y. If you start with this line down here, you already found y, so you do fyx, you take the derivative with respect to x, but they lead to the same place. And we're gonna show that one time here. That's what you would see in the classroom. So the derivative with respect to y for these, you know, x is now a constant, so it's 8 times the 48. It's the power rule there. So that's 320 plus 64, so it's 384 y to the 7th, x to the 5th. And then here 5 times 42, because with respect to y, would be 210 y to the 4th, x to the 6th. Now we're gonna show that it's the same down here. So if we go down to this line and we take the derivative with respect to x, which means x is your derivative, which means power rule. So 6 times 64, okay, believe it or not, that's 384, x to the 5th, y to the 6th. Wait, did I not? I messed up somewhere. Uh-oh. Oh, this should be an 8. I messed that up bad. No, that's not right. Uh-oh. Okay, there's a mistake here. Let me see if I can, let me keep going on this one, see if I can find it. Plus with respect to x, right? No, that's y to the 7th. Oh no, I'm sorry. That is right. So it's just out of order. That's what I was not seeing. So see how that's the same, and the x to the 5th and y to the 6th the same. And then here, 7 times 24 is 140. That's not right. Did I not? What's going on here? 210. Sorry, just making fumbling around here. Let me fix this. 7 times All right, let me go back. I don't know why this is such a mess up here. 48 y to the 8th x to the 5th plus 42. Why did I increase that? So that's part of the problem here. I messed up some exponents. I don't know why I did that, but that's supposed to be a 4. Let me just correct this. 4 times that gives you 168 y cubed x to the 6th. Now I think it's going to work. 7 times that gives you 168 x to the 6th y cubed. Okay, so I did mess up a few places here and apologize for that. I think I've corrected. There's a 5 there. Yeah, that's right. That's right. Okay, so I was trying to show you that these are the same, and they are, but I really got turned around here on this. If this is really critical, I can double check this one more time.
Okay.
It's up to you. If you'd like me to do that. I think I'm feeling pretty good about it right now. You know, these are the boxes you need, but just check your exponents that they're, because I modified a few of them.
Okay, let me just type them in really quickly.
Okay.
So the first fxx, that's actually 42 instead. Why
Yes, it should be 42 y to the 4th x to the 6th. There are also many calculators out there that will do this for you. You know, but just keep in mind that so I think this is, I'm pretty sure this is good. The next one I didn't make any changes to because it was 8 and then 7 and then it was 4 and then it was 3. That looked good. And these ended up working out nicely. And you can actually just copy and paste from x, fxy, fyx. You don't have to actually, they can be exactly the same because they are.
Okay. Right, should have just sent.
Right. Let me check it out. There it is. Okay, this I appreciate you being patient with me. These will be much. This should be much clearer. These next couple. All right. Okay, so the question here is to find, you know, e fxx, and then you know, all the same ones we've been doing. So one possible rewrite here, which I don't think is needed. Well, actually, let's not even do that. The derivative of e fx, derivative of this with respect to itself is itself, but then you have to take the derivative of the exponent here. Y is a constant, so it's just 2y.
Okay.
Is that okay? Is that,
yeah, because you're solving for x, so that x like gets removed, right?
Yeah, yeah.
Okay.
And it's good. It's actually good to rewrite this because you're going to use the answer because you got to take another derivative here. So your next derivative, like it might look like product rule, but it's not, because this y is just a constant. It's like saying 25 in front, doesn't matter. So you actually just keep that constant. Derivative of e to the 2xy is itself. And then again, you take the derivative of the inside function. The derivative of the inside function is 2y. Again, with respect to x, because we're going with respect to x, okay? So that gives you 4y squared e to the 2xy.
Okay. Okay. So then if you're solving for the x, y, so for like the y,
Yeah.
you would do,
Fy is going to look really similar.
yeah. Would it just be the same thing but x instead?
Yes.
Would be,
Yes.
okay.
So fyy, yeah, becomes the same thing. It becomes 2x e to the 2xy, which is 4x squared e to the 2xy.
Okay. And then so for 4xy,
For this, we're doing this one next, fxy.
yes.
So you start with this one right here. So you say, okay, my fx is 2y e to the 2xy, and you take the derivative of this with respect to y, which is now product rule, because your y is your variable. So if you, and this is a little better example, you have to treat like this is your first function and then this is your second function, but you're taking the derivative with respect to y this time.
Okay.
So it's product rule here. Is that?
Yeah. That'd be 2y, and then that's just e to xy, right?
Right? But the
Plus,
derivative of this, you got to take the derivative of this now with respect to y. So it's 2x plus.
the same thing, right?
Well,
Oh,
the
no.
yeah, derivative of that's 2, and then you keep the second.
Equals,
So we got 4xy e to the 2xy plus 2e to the 2xy.
yes.
And your fyx is exactly the same.
Okay. Are they all going to be like the exact same?
Yes, these are always the same. Like in calculus 3, and maybe if you're inside a classroom, the instructor would make a big deal out of this, but they're just the same. Like there's no
Okay.
reason to like get all excited because you just want the answer.
That's good to know. And then I will screenshot the other one right now. Okay, should have just sent.
All right, let me check that out. There it is. Okay, yeah. Oh, so this one finally, if you look at the third box there, it's like telling you like, oh, hey, by the way, they're the same.
Oh, okay.
Which, not sure why they didn't tell you sooner. So this one is let's just do Rx, and that doesn't matter, the fact that it's R, it just means it's a function of two variables. You're just looking at the right-hand side. And unfortunately, this is quotient rule.
Yeah.
So if you don't remember quotient rule, the derivative here, it's bottom times root of top minus top times root of bottom over the bottom squared. Because there's variables x in both the top and the bottom, that's why it's quotient rule. It's not just because it's a quotient, it's because there's literally x in the top and the bottom. So and this gets really horrible when we do second derivative, but let's go here. So the top is 6x plus 5y times the derivative of this with respect to x. So it's just y minus xy, because that's the top, times root of the bottom with respect to x, which is 6, all over the bottom squared, 6x plus 5y squared. And we definitely want to simplify this. This up here becomes 6xy plus 5y squared minus 6xy.
Mhm.
So nicely those cancel. So you just get 5y squared over 6x plus 5y squared as your Rx. We don't even want that. We want another derivative. So Rxx, because there's no x in the top, it's no longer quotient rule. It's actually just power rule. And if that's not clear, this can be written as 5y squared 6x plus 5y to the minus 2 power.
Mhm.
And this is just a constant out in front. So you don't use product rule, you don't use quotient rule, it's just power rule. So it's negative 10 y squared 6x plus 5y to the minus 3 power. But then you have to take the derivative of the inside function with respect to x, which is just 6. The derivative of 6x plus 5y with respect to x is just 6. And if you want to make this nice looking, it becomes negative 60 y squared over 6x plus 5y to the power of a positive 3. That is your final answer for Rxx.
Okay.
All right, so I'm going to kind of start again down here for Ryy.
Okay.
And it's the same. It's just okay. Now it's y instead of x. It's quotient rule because there's a y in the top and on the bottom. So it's the bottom times the derivative of the top with respect to y, which is just x, minus the top times the derivative of the bottom with respect to y. So it's just the 5 over the bottom squared.
Okay.
So just a light amount of simplifying. It's 6x squared plus 5xy minus 5xy. So you get 6x squared over 6x plus 5y quantity squared.
And then would be the first derivative, right?
That's the first derivative, Ry, but we got to keep going. And again, like this can be rewritten, which I think is very helpful to do, as 6x squared 6x plus 5y to the minus 2 power.
Mhm.
And then use power rule, because when you're taking the derivative with respect to y, this right here is just treated as a constant, like it's a number. So it's negative 12x squared, right? Multiply that, 6x plus 5y to the minus 3. Then you got to take the derivative of the inside function with respect to y, which is just the 5. And if we write it out nicely, it's minus 60x squared over 6x plus 5y cubed. And you'll probably notice it looks really similar to this up here,
Mhm.
and it always will. So like if you think you're going to get this question on the test, like just make sure you do it one way and figure out how the other way looks, and it'll be very similar.
Okay.
But there's no reason you can absolutely do this. It sounds like you're pretty comfortable with what we've been doing thus far.
Yeah, it seems like a lot of them are just like the same answer, just X and Y.
Yes, very much so. Not always the case, but for this class, we can safely assume that. Okay, so now to do the last one, we either have to start from our x or our y. I don't think it matters, but I'm going to start from our y because more generally we're comfortable taking derivatives with respect to x.
Okay.
So this is our y. So our yx is taking the derivative of this with respect to x, and it's quite awful. It's another quotient rule. So it's the bottom times the derivative of the top with respect to x, that's 12x, minus the top times the derivative of the bottom with respect to x, that's times 2, 6x plus 5y to the power of 1. Then you get a chain rule derivative of the inside function 6, all over the bottom squared, 6x plus 5y to the power of 4. This does simplify. Sometimes Pearson will take it like this. I think Love will. I don't really remember. But you might have to simplify. We can do that if you would like.
Yeah, just because that is like confusing for me to look at.
Okay, so do you see how there's a 6x plus 5y on both positions here?
Yes.
So we can factor one of those out
Okay.
and cancel with one down here.
Okay.
So it becomes 6x plus 5y, because there's now one of them, times 12x minus 6x squared times 2 times 6, and then over 6x plus 5y to the power of 3. We're not done, but that's that intermediate step there. So now we've got to distribute in. Okay, so that gives you 72x squared plus 60xy minus 72x squared. So notice how we have some cancellations again. And you get 60xy over 6x plus 5y to the power of 3.
Yes, it's a lot easier for me to understand.
Yeah, a lot easier to enter also. I mean, it's like, the more mistakes are made probably entering answers than a lot of other things.
Okay. I'll send the next one over in a second.
Okay.
Alrighty, I just sent it.
All right, let me take a look here. There it is. All right. So lovely word problem, story problem here. Is this the last question?
Yeah.
Okay. Should do this. So they give you a they give you some formula here. And they say the temperature humidity index is TH. So you have to take the derivative. Oh, actually they give you TH. Okay, never mind. So they give you TH. I think you just got to put these numbers in for T, and then H would be 0.62.
Oh, okay.
So it's like 1.98 times 87 minus 1.09 times 1 minus 0.62 times 87 minus 58 or minus 56.9, and then one decimal place. So let me calculate this also. Hopefully we get the same thing for this.
So I got 103.35 degrees.
Okay, so we'll go 103.4. I am not close. I'm still entering this in. If you want to check, let me just check those times. H times. That seems really high for even me. Like we have heat indexes like that, I guess, here, but that seems really high. I don't know. But I guess the humidity is pretty high. So I guess the point is like if there's a lot of humidity, it's going to feel hotter than where it actually is. And I get the same thing. Although I get 103.3.
Yeah, 103.3.
Yeah, I guess okay. All right. That's, I guess if I were entering, that's what I would go with. All right. Well, that does take us to the end of our lesson today. I'll send you the notes out shortly and then a link to the screen recording if you need to look at it later for review.
Okay.
Thanks for listening. Sorry about the issues from scheduling.
That's okay. That's my fault.
Always text or email if there's an issue like you did. I'll be happy to work it out with you. So
Okay, perfect.
appreciate it. Hope you have a great day. Bye now.
Well, bye.